This video will cover notes 3-12. So we have talked about functions, their domain, the range, and whether something is a function. And we looked at equations that are functions. So our example here is y equals 4x minus 1. What we're going to learn now is just a new way to write a function. Instead of using y equals, we do something called function notation. So all we will be doing is replacing the y with this notation, an f, and then parentheses, x equals, and then we put the same thing, 4x minus 1. So the only thing you are doing is you are changing the y to f of x, we call it, f with the parentheses and x. So we read this as f of x equals, and then ours is 4x minus 1, but it will be whatever the function is. So instead of saying y equals, we say f of x equals. That's the only difference. I know it looks super weird, but the only difference is you are exchanging out the y for f of x. So f of x is your y, so that is the range or the output. And then x is the domain or input. So it will tell you either what the f of x is, and we'll get to that later on, or it will tell you what the x is. So you are going to put that in for the function. So instead of this saying y equals f of x, find y when x equals -7, this is just a different way to write it. So as you can see, you are going to look at f of x, and you are going to look at f of -7 in this case. So what you notice is that they changed an x to a -7. So wherever there's an x in this first function, you're going to put a -7. So we're going to write f of -7 equals 4 times -7 minus 1. It's a lot easier just to always put your number in parentheses, or think about replacing the x with parentheses first and then putting the number back into those parentheses. After that, it's just evaluating exactly what you did when it was a y equals, or what we did clear back in Unit 1 when we were doing order of operations. Sorry about that. So this is -28 minus 1, which is -29. So your final answer for that is -29. So again, all you do is rewrite the problem, whatever the number they have inside the parentheses. In this case, it was -7. That's what you need to put in wherever the variable is. So if we look at number 1, f of x is x plus 7. We are finding f of 5. Some of you can do that just in your head, but I do want you to practice writing out f of 5 equals 5 plus 7. So then 5 plus 7, our final answer is 12. So rewrite it by plugging the number in that they give you, and then do the math to figure out what your answer is. So we could have the ordered pair 5, 12. That's what we're really finding, is those ordered pairs. Number 2, g of x is 3x minus 8. We need to find g of -3. So wherever the x is, if it helps you to underline it like I just did, we need to put -3. So g of -3 equals 3 times -3 minus 8. So I use parentheses there. If you want to use a multiplication sign, that's fine, as long as you know to multiply. We would get -9 minus 8, so -17 is our answer for g of -3. Number 3, h of x is 2/3 x minus 1. We are asked to find h of 9. So again, where the x is, we're going to put a 9. h of 9 equals 2/3 times 9 minus 1. I know most of you don't like to rewrite it, but you need to take the time to write out that first line. 2/3 times 9 gives us 6. So 6 minus 1 gives us 5 for our final answer. Number 4, we're finding f of negative 4. Here we have exponents, so this time you have to be very careful, and you do need to put your negative 4 in parentheses for sure. F of negative 4 equals parentheses negative 4 with the squared on the outside. We are squaring negative 4 minus negative 4. I'm going to put it in parentheses just so we separate the minus and the negative. Negative 4 squared is 16. I know that minus negative is really plus positive. If you want to leave it as minus negative, you can in your calculator and just type it in. That's fine. You should get 20 for your final answer for that one. Number 5, we're finding f of 5, but here you have to be careful with this negative sign. That does not go inside the parentheses. We are squaring 5 and making it negative. So it should look like this. F of 5 equals negative parenthesis 5 squared plus 6 parenthesis 5 minus 4. So 5 squared is 25, and then you put the negative with it. So negative 25 plus 30 minus 4. We end up with 1 for our final answer. So super important to remember the difference between what we did in 4 and what we did in 5. Number 4 wanted us to square whatever our x value was, which was negative 4. So negative times negative is positive 16. In number 5, they wanted us to square first and then make it negative. So 5 squared is 25, and then we make it negative for negative 25. Number 6, we have g of x equals negative 1/2 x plus 9, and we need to find g of negative 8. So g of negative 8 equals negative 1/2 times negative 8 plus 9. So that's 4 plus 9, which is 13 for our final answer. Number 7, we have another negative that we're squaring, and we're multiplying it by 2. You do not multiply first, so write it out exactly like this. F of negative 5 equals 2 parentheses negative 5 squared plus 4 times negative 5 minus 9. So this says we need to do negative 5 squared, which is positive 25, then multiply it by 2. You're not squaring negative 10. You are squaring negative 5 and then multiplying by 2. So our first number changes to 50 minus 20, or if you want to put plus negative 20, that's fine, and then minus 9. That ends up being 21 for our final answer. Number 8, we need to remember that those are absolute value signs. So g of negative 7 equals absolute value negative 7 minus parenthesis negative 7 squared on the outside with the absolute value. You're going to have to bring your absolute value down while you do your work for this. Absolute value negative 7 minus 49. We do not change those both to positives. You do all of the work before you to get down to one number, which is negative 56. Then we take the absolute value of negative 56 to get positive 56 for our final answer. So again, even though these problems look really scary, all you're doing is you're replacing the x with whatever number they give you inside the parentheses after your function. It's called function notation.